So amount times percent plus amount times percent equals amount times percent. So, I don't know, if you have turned this in before today, you have it back. If you turn it in today, you don't have it. But the homework 1.7, number 1. All right, so here we go. I have 18% and 31%, and I want to end up with 21%, okay? How much? 18 gallons of that, so the amount of that is 18. Okay, so I have a nice equation here to solve, if only I knew what goes in that parentheses. Well, what goes in that parentheses? 18 plus x. Now, do be careful, because occasionally they'll say we want to end up with 18 gallons in the end. And if that's the case, then what will this be? 18 minus x, right?
I'm so glad you taught it this way. You were taught, I was taught a different way last year, and it made no sense. This makes so much sense.
Perfect.
You're the best teacher ever in this world.
Okay. And you know, okay, we're still taking a test tomorrow.
Oh, no, I'm just saying.
Okay.
But all questions to that.
Okay.
Credit.
No. All right. Although I do have, a couple of bonuses tomorrow. Well, there's a math bonus, it's hard. But then there's, you know how I had you, on the last test, you had to name, had to name who built this, okay, and almost all of you missed it. There's one of those. But I've got different versions of the test this time. I thought I could give one. It didn't work last time. We had some cheating. So we got different versions of the test this time. And I think one of my questions is a little easier than the other, but it's just going to be luck of the draw. It's going to be the luck of the draw. So.
Is it going to be like a history question like last time?
Cathedral history type question, yeah. Just a cathedral common interest story question. All right, so I'm using my calculator to help me with the arithmetic. Yeah, Mary Ann Stewart is a Providence nun. So I am getting, I think that's 60, let me double check. Yep, so I'm getting 60 gallons. Okay, Jackson? All right, anybody else from any papers, homework, quiz, or review sheet? Anything else we need to do? What, Peter?
4 on this.
All right, so review 1.5 to 1.7. Problem number 4. Well, I'm not doing it. Which one do you want me to do? Find the inverse of which one?
A minus E.
No, it says A through E. It refers back to problem 3.
Oh, I thought it was saying A minus
So
E.
A through E.
Okay, then never mind.
All right, cancel that. Anybody find another one?
Can you do number 4 on the page behind it, the number 2? 1.5 to 1.7, number 2.
1.5, 1.7, review number 2.
Yeah.
Yep, which one?
4.
Number 4. So this is another, okay, we just did one like this. This is another set of parametric equations. And this time it says, find an equation in x and y that represents this set of points. So basically, what do we need to do? Write one equation without any t's. So you can either substitute them out or eliminate them out. I think in this it makes sense, to substitute because we don't have a squared, and to get a squared, we have to do a bunch of FOILing. So I think I'm just gonna solve for t in the top equation and then plug it in here. So y equals x minus 1 squared. And that's it. That's my equation with just x's and y's and no more t's. Okay?
So for that, do we need to expand on it, or is it okay if we expand on it, or should we just leave it like that?
You mean FOIL it out?
Yeah.
It wouldn't make any difference if you FOIL it out or not. There's nothing, like if it had plus 7t minus 3 or plus 7x minus something, then I would multiply it out so I could collect my terms. But there's no benefit to multiplying out, but it certainly doesn't hurt to multiply it out. So, Karen?
Can we do number 4 on the very back of the packet?
Well, it depends what the very back of the packet is.
Like if the staple is on the bottom right corner.
The staple's on the bottom right corner. Number 4 says, prove that these are inverses. All right, now this is a proof. There's only one way to actually prove two things are inverses. Prove numbers, how that's done. Plug one into the other, and then do the opposite, do it both ways. So, we have to build the composition f of g of x. So, that one would be take g and plug it in to f. So 2x minus 1 over 2 plus 1. Take function g, and plug it in for x in f, and then simplify. And what should happen? You better get x, which we did. Then you turn around and do the opposite. Plug f into g. So 2x plus 1 minus 1 over 2 is 2x over 2, which is also x. So that is your proof. That's the only way to do it. You have to plug one into the other, and the other into the other, and then you got it. As long as you end up with x.
What's the one where you don't have to do all that?